Hello everyone, welcome back to General Chemistry lecture series, and we are studying right now chapter number 1. And in my previous video I have gone through with the two topics, this chemistry and matter, and this second topic is classification of matter. And now in this video we will study about the nature of the energy and the unit of measurements. This properties of matter and the nature of energy. So this will be the second topic to study. So let's start these two topics and hopefully you will like it. Okay. So in this video we will study about the properties of matter. So mainly matter has two types of properties. One is called physical property, another is chemical property. So physical properties, what are the definition both of them? So physical properties can be observed without changing of a substance into another substance. So the physical property in which we are not going to change any chemically the substance, and the physical property is like a appearance, morphology, outside what it look like. So that is called the physical properties that can be observed without changing any substance into another substance. So let's take an example of the physical properties. So if for an example, color, odor, density, melting point, boiling point, and hardness and softness. So good example is this. So if we see anything, any building, and then we recognize its that building by its changing its color or its appearance. So that is a kind of physical property of a building. And what about the chemical changes? So chemical properties can be observed when a substance is changed into another substance. So it means matter can be converted into one matter to another matter. So for an example, the best example is the burning of coal or wood. So flammability, or the ability to burn in oxygen. So if we burn hydrogen gas in presence of oxygen, it forms water molecules. So water has a different chemical properties than the hydrogen and oxygen. So this kind of change from one chemical to another chemical is called the chemical properties. And the same way it's defined another way all the physical changes and the chemical changes. So physical changes are the changes in the matter that do not change the composition of a substance. So and that is related with the physical properties. So physical properties depend on the physical changes. For an example, change of a state or temperature and volume. So if we are changing the state of a physical of a matter, like a liquid to solid, solid to gas, or if we are changing the temperature of a substance, any matter, or if we are changing any volume of the matter, like converting 1 glass of water into the 2 cups of water. So it does not, this is called the physical change. And again the physical change and the chemical change is exactly same as a chemical properties. So chemical changes results in a new substance. So here, as we have seen, the water and oxygen reacted and they form a new substance that is called water. So hydrogen gas, oxygen gas, when they burn together they form water molecule. So example of chemical changes is combustion, means burning, oxidation, this reaction is called the oxidation, and then decomposition. So like if you throw any vegetable outside in the garbage, so it slowly changes its decompose. So that is a decomposition. And the good examples for the physical change, just like I said the state of change in the state. So state means like it is changing. Ice, water is in the form of ice, which is solid state, which is changing into liquid state. Water is a liquid state, and then here is a solid. and then once we will heat this one, it become vapor phase, so it become like a gaseous phase. So solid to liquid, liquid to gas, or any interconversion is a physical change. And then another example is for chemical change, like if we have a copper painting, and when we, which is composed of copper to nitrate, and when we add the copper painting into nitric acid, it's a strong acid, then it dissolve into copper, and you can see a brown color of gas will evaporate, that is N2O. So this kind of when substance or matter changes from one form to another, it's a chemical change. So let's see the other terminology. In the first chapter there are two terms also came, like intensive properties and extensive properties. So what are the intensive properties? Intensive properties are characteristic of substance whose value do not depend on the amount of material chosen. It means not changes if matter is divided. So if we divide any matter into 2 or 3 or 4 pieces, if the property is not changing, that is called intensive properties. For an example, temperature or melting point, or color, or like a physical state. So those are the good example of intensive properties. And extensive properties are the characteristics of the substances whose value do depend on the amount of material chosen. So and extensive property changes if the matter is divided. So basically, if matter is divided into two parts, so the mass will change, volume will change, and the heat capacity will change. So if any property that changes, it means that is extensive properties. And now here is a one question for you. So which of the following is an extensive properties? You can pause this video and then think about what would be the best answer. The boiling point, color, temperature, volume and density. What would be the best answer for this question? Which of the following is an extensive properties? So as I said, so you can pause this video and then think about, and then I will answer you. So let's understand. So this if you understand the example, basic definition of the intensive property and extensive property. So intensive properties do not changes if matter is divided, and extensive properties changes if matter is divided. So if we are dividing any matter, will the boiling point change? No, because the matter is same. Will color is change? No, matter is same. Temperature will change? No. Volume will change? Yes, it will be half, so volume will change. Density will change? Probably not. So good example is if we are dividing like a chocolate bar into two pieces, so what will happen here? So brown color chocolate will remain both sides on the brown, right? Boiling point of the chocolate will remain same. Temperature, if we are dividing at room temperature, the temperature will remain same. Density of the chocolate will also remain same, but the volume from this long bar is going to be short into two pieces, so the volume will change. So volume will be the best example answer for this question. So let's see next thing is the separation of mixture. So if we have to separate the two mixtures, what are the methods? So basically there are three methods used in separation of matter. Number one is called filtration. So filtration means like if we filter coffee from the coffee pot, or tea from the tea bag pots. So separation of a sand from a sea water. So this is the one example. If we have two independent matter which they are not dissolving or not mixing together, then you can separate by filtration. Distillation is the separation of water from the salt water. So distillation is like if the two matters are dissolved together, and one matter you can boil it and then condense it, so then you can separate two mixtures. So when we will evaporate the salt water, you can condense the vapor of water and get the clean water, and in the remaining part in the other container will be the salt, pure salt. So the third is chromatography. So chromatography method is mostly used in the organic mixture separation. So separation of ink on the paper or separation of an organic compound through silica gel, and that is called the organic column chromatography. So in column chromatography what happen, so we take this kind of big column which have a stopper here or frit you can say. We fill this column with the silica gel, and then we load our compound number A and plus B, or if we have 2-3 compound, and then we added solvent on the top of this one, and then if the compound is A is a more polar, it will remain here A, and if it is less polar, usually silica gel, normal silica gel elute the non-polar compound first, so B will come first, B, the compound of B band will come first, and compound which have the A band will elute later on. So this is the same method is used for the separation of different ink on the paper. So let's see another question for this topic. Which of the following is not a homogeneous mixture? So this is the question on the type of matter. So hot tea, sugar and water, cherry coal aid, salt and water, oil and water. So you can pause this video and answer this question. Which of the following is not a homogeneous mixture? Okay, so if we see hot tea is a mixture of tea in the water which you cannot see, and it's usually it's a transparent. So this is a good example of homogeneous mixture. Sugar and water, when you mix sugar and water, they mix together and you cannot separate them. So this is also is a homogeneous mixture. Cherry coal add is also colorful water which have other nutrients. So that is also a homogeneous mixture. Salt and water, this is also when you will mix salt into water, it is a homogeneous mixture, you cannot separate it, you cannot see it, it will be like a transparent solution. And then oil and the water, so this is the answer for this question. When you will mix oil drops into water, they will be separate into two layers. So water will be at the bottom and the oil will be on the top, because oil have a less density and water has more density. So water is heavier than the oil. So this is a good example of which is not a homogeneous mixture. Okay, we will discuss about the density in the other lectures. So next topic, this topic is added briefly in this chapter, which is going to be studied in chapter number 5, which is called thermodynamics. But let's go over very quickly. Energy, there are few terms we have to understand. So energy is the capacity to do work, transfer heat. So energy is a power or force or capacity to do the work or transfer the heat. And what is the work? So work is the energy transfer when a force exerted on an object causes a displacement of an object. So basically, if this is a rock and if you are moving by applying force, moving from here to here, so basically this is called the work done. Work means So the energy transfer, we are transferring energy on this body energy to this rock to move from A point to B point. So this is called work. And the heat is the energy used to cause the temperature of an object to increase, that is the heat. So these are the terminology. And the last here is force, is any push or pull of an object, so that is called the force. So this was the brief about the energy, and then let's talk about the types of energy. So basically there are two fundamental forms of energy are there. One is kinetic energy, another is potential energy. So kinetic energy is the energy of a motion, and its magnitude depend on the object's mass and its velocity. So basically if anything is moving, it means it has a kinetic energy, and if it is any object is sitting, it means it has a potential energy of an so potential energy definition is of an object depend on its relative position compared to its object. So here is an example. So if we have a ball on the uphill, so this ball have a high potential energy and kinetic energy is zero kinetic energy. But when it is rolling on the downhill, so basically we are decreasing it is decreasing its own potential energy, but it is increasing its kinetic energy. So if we are driving the car, it is going on the downhill, so basically the car is getting more kinetic energy and it is losing its potential energy. But when it is driving on the flat surface, it has more high potential energy but less kinetic energy. So this was all about this second section, which is the properties of matter and the energy. And then if you have any question, please type here, and then I will try to answer you. And next video we will study the other topics.